Okay, we'll see how long the microphone works now in this one. Made it so far. So, what do we come up with? For tangent is equal to the square root of 3 over 3. Okay? Tangent is equal to the square root 3 over 3. So where's that going to happen? Where's one where it'll happen? At pi over 6? Yes? You guys realize that in quadrant 1 on your unit circles, those numbers outside, that's the tangent values, right? Right? Okay? So square root of 3 over 3 is going to happen at pi over 6, right? So it happens basically when the x value has the square root of 3 in it, and the y value is the 1/2. So that means that it would also happen at 7 pi over 6. Okay? Which one of those is in my restricted values? 7 pi over 6. So let's just test it to make sure. So tangent is y divided by x, correct? Yes? Okay, so that's going to be negative 1/2 divided by negative square root 3 over 2, or times negative square root 3 under 2, okay, when we flip it over. Okay, so that gives me positive 1 over the square root of 3, which if I multiply by the square root of 3 over the square root of 3, then I get the square root of 3 over 3, which is what I want. Okay. Cosecant equals negative 2. What's another way of writing that? We got help? Okay. I won't let you be right. What? But another, because cosecant is not on here. It's what? It's the reciprocal of sine, right? So if I reciprocal negative 2, what do I get? Negative 1/2. So this is where the sine of theta is negative 1/2. Well, where is the sine of theta equal to negative 1/2? What two values? 7 pi over 6 and which one? And 11 pi over 6. So these are at 7 pi over 6 or 11 pi over 6. Which one is in my restrictions then? 11 pi over 6. So theta here is 11 pi over 6. Okay? Handle? Take a step back and let's do some right triangle type trig. Okay? So find me the 3 things that I'm looking for in terms of those 3 problems, please. Then this is my adjacent side and that is my hypotenuse. So if I remember my SOHCAHTOA and TOA, that's going to be cosine degrees is equal to 23 over x. So x is going to be equal to 23 divided by the cosine of 39 degrees. Checking my calculator to make sure that I am in degrees here and not radians. So if you're using a regular type calculator, make sure that you're in DEG, or sometimes they just say D. If you're on an Inspire, use the degree symbol, which is found in the pi key. Okay? So 23 divided by the cosine of 39 gets me x here is equal to x here is equal to 29 point, let's go 595. Agree with that? Okay. Here then, I would be there. That means this is my hypotenuse. That's my opposite side. So then the sine of 66 degrees is equal to x over 50. So x here is going to equal 50 times the sine of 66 degrees. That's going to give me x here is equal to 45.677 units. Agree. Okay. Here's my angle. That's my opposite. That's my adjacent. That tells me tangent of theta is equal to 9 over 12. Row, what do I got to use? Got to use my inverse functions. So theta here is going to equal the inverse tangent of 9/12. If you went 3/4 there, I'd be just happy with that too. So then we have inverse tangent of 9 divided by 12 gets me theta here in degrees. Theta is 36.870 degrees there. If I went in radians, that would be 0.644 radians. Okay? So, using what you know about the unit circle, find me those 4 values using what you know about t. So the sine of t is 8 over 17. Okay? Now, there are 2 different ways that you can go about thinking of this. Okay? The first way is you could say, well, if the sine of t is 8 over 17, that means that my right triangle is set up like that. Okay? And you could use our old friend Pythagorean to find the other side, which is 15. Agree? Okay? The other way is you could use the hammer. And you could say that the cosine squared of t plus the sine squared of t is equal to 1. And since the sine of t is that, okay, 8 over 17 squared is 64 over 289. So let's call it x instead. Oops, tap the brakes. Oops, 289. Right? So then x squared here is going to be 225 over 289, or x, which is your cosine, is plus or minus 15 over 17. Because when you take the square root and you're solving, you gotta bring in that plus or minus. Okay? Now, thinking about it triangle way, how do I get that plus or minus in there? Because the answer is here, for the cosine of t, the answer is plus or minus 15 over 17. Which two quadrants does positive sine live in? First two, first and second, right? The top half of your unit circle is where they live in. Well, in quadrant 1, the cosine is positive, but in quadrant 2, cosine is negative. So you have to give both there. Okay? Now, number 2 on the unit circle says that the sine of negative t is equal to the negative sine of t. Number 2 formula. You found it on one of the blue packets. Okay? So that means that this one is going to be negative 8 over 17. The tangent of t is going to be my sine of t, which was 8 over 17, divided by the cosine of t, which is plus or minus 15 17ths. So that's going to be 8 over 17 times 17 over plus or minus 15. So that's going to give me plus or minus 8 15ths. Again, depending upon which quadrant you're in, and since it didn't restrict what quadrant we're in, we have to give them both. Okay. The sine of t plus 5 is formula number 9, so that is equal to the negative sine of t. So that one, again, is negative 8 over 17. Okay? You try these ones. Try those ones. So where can t be located in this one? Negative cosine value. Where can t be located? Second or third quadrant. Okay. The cosine of negative t is equal to the cosine of t. So that one is going to be negative 5/13. the cosine of t minus pi is going to be equal to the negative of the cosine of t. So that's going to be positive 5/13. Okay. Sine of t. If you went triangle-wise, 13 would be there, 5 would be there. Pythagorean tells me that that one is 12. If you went hammer-wise, that would be negative 5/13 squared. Oops, not equals. Plus the sine squared of t is equal to 1. So 25 1/69 plus something equals 169 1/69. So sine here then would equal, or sine squared I should say, of t is going to equal 144 over 169. So then the sine of t is going to be plus or minus 12/13. So that one here is plus or minus 12/13. Yes? Okay. Believe that there was anything else below that? No, there was not. Okay. So now it says find theta with a calculator in both degrees and radians. Okay? So whichever mode your calculator is in, you can find it, and then you can just convert that into the other one. Okay? So cosine, remember, the inverse cosine, the inverse sine, and the inverse tangent ones are all of my theta finders. Okay? So cosine, the inverse cosine, oops, tap the brakes, gotta hit the inverse cosine, of 5/13 gives me a degree measure here of 67.380 degrees. In radians, that gives me 1.176 radians. Yes? Okay? All right. What I would like you to do now, and in the remaining 30 seconds of class that we have, you should be easily able to do those two problems, is find me both degrees and radians of those. Agree with me so far? Yep. Have a good day. Thanks for staying an extra 30 seconds.